Okay, I want to start this morning by sharing a video with you.
Some estimates the English language contains nearly 500,000 words. And yet, when we tap out text messages on our phones, the keyboard's predictions of what we'll type next are usually right. So, how does it know what we'll text next? This is Algorithmics, the space where we explore how invisible, computer-controlled, database sets of rules are making decisions for us every day. Over time, a predictive text system uses machine learning to figure out which words you tend to use. It creates a sort of personalized dictionary of these words, and it scores them based on the probability that you'll use them again. The higher the score, the more likely the word will be suggested to you as you type. Say you're often telling friends, "Thanks for coming over." If you type the letters THA, the keyboard will suggest thanks. Someone else might not use the word thanks all that much in text, so when they type THA, they might get a suggestion of the word that's. You can even add words that aren't in the regular dictionary, like an inside joke or unique name, to your personal text dictionary. But advanced predictive keyboards can even go a step further. They use probabilistic language modeling to consider context, how certain words tend to go together in language. So, type the word why, and your next suggestion might be do. Type the phrase a little, and the keyboard might suggest bit. This combination of machine learning and language probability is the core of most predictive text systems, and each offering puts its own spin on the algorithm. For example, the swipe keyboard includes a living language feature, which updates your dictionary with slang words and phrases found online and in social media. Of course, the algorithm isn't perfect. You're bound to get an autocorrect fail from time to time. But largely, predictive text systems are pretty spot on. So type ALG for the algorithm.
Okay, that talked about. Oh, hang on, that's me. Okay, that talked about some of the stuff that we talked about last time. It went into like the fact that the probabilistic aspect where you build a dictionary and assign probabilities to words. It talked a little bit about the um, you know ties between different words, and it didn't go into the specific kinds of errors where you type a nearby key or transpose two letters, but that's a little bit more advanced, and they could put into a 3-minute video. Um, okay, um, so I want to talk a little bit about the rest of the course. I have covered most of the topics that I really intended to cover this course. So I want to talk a little bit about the scheduling and how the rest of the course will go. On the original syllabus for the course, it said that we were going to have some assignments, a midterm, final exam, and the project. If Unless anybody objects, I'd like to sort of just get rid of the midterm. Anybody, any problems with that? Okay, let's just get rid of that. The more I thought about it, the less I thought it made sense in the context of this semester. There will be a fine. Yes, Jalen.
So you just want us to focus on our project?
Starting today, I'm pretty much going to ask you to focus on your project. There is going to be one more assignment that's going to be like for everybody, and then your individual projects. So that one more assignment is going to get posted this weekend. It's not going to be huge. But for the last 2 weeks, you're gonna focus on that assignment, and I'm of course happy to answer questions, and on your project. And then the last the last couple days, um, I'll go through exactly what's going to be on the final exam. So if it's okay, no midterm. We'll get you going on your projects. Make sure that the question that you want to ask is very specific. That at some point in your attempt to analyze whatever you're going to analyze, you're using some of the techniques that we've learned in this course. Um, and so we should have plenty of time to talk this thing back and forth. I'm going to be available to you all, basically all during the classes for the next 2 weeks to ask questions on. But I do want you to focus on your projects, and then we'll get back together close to the end to talk about the final. Now, in terms of your projects, what I want you to actually submit is a short write-up, say a couple pages. You can have diagrams in there. You can have charts and all sorts of things. However, use whatever sort of medium you think explains your solution best. Don't leave words out. I find in math, students often feel like they can't put words in. I want you to have words and paragraphs and things. That's all good. Words help explain ideas. They're a great tool. So make sure there are enough words in there that you can explain the problem and explain your solution, explain how your model works. Then you're going to give a presentation on it. I haven't 100% decided about the presentation. I think we have, like, there's 8 of you here. I think there are still 9 people registered in the course. I think we'll take 2 days to do the presentations, probably the Wednesday and the Friday of the last week. We'll do the presentations, and maybe we'll take Monday of the last week for review for the final exam. That should allow us to fit things in nicely. We could possibly play around with that and put the review for the final exam on Friday and the presentations Monday, Wednesday. But the presentations and the review will all be the last week of class. And I'm happy to take input from you, whatever works out best in that regard for your own scheduling. And if we're gonna do 8 or 9 of you in 2 days, then each of you should have, like, let's say, like 10 minutes, including questions from me and from the rest of the class to do your presentation. I want you to be both professional and relaxed. We're already doing Zoom meetings, which puts extra stress on everybody. You can do your presentation however you want. And by that, I mean, if you want, you can put together a PowerPoint presentation, or if you want to stand in front of a blackboard or a whiteboard or whatever, you're welcome to do that too. Write out a big chart on your wall, whatever. No messing up your parents' houses. I don't want to get in trouble for that. What I don't recommend you do, and I wouldn't mention this except for the fact that I ran into trouble once in the past, there should be something with writing on it. It is very difficult, practically impossible to follow a math talk just verbally. I had a student try that once, and it was a disaster. You'll be graded on, how well you present, and you'll be graded on the model that you've built. And that's basically how it's all going to come together. So, as I said, for the rest of this class and for all of next week, I am just here to talk things over with. So let's see, some of you have already discussed your problems with me in some level of specificity. Not everybody has, though. So if you haven't, let me know and I can help you. Those of you that have already started, you know that what I suggest is that you choose an idea which is interesting to you. And once you suggest sort of a general region, I can help you narrow things down. Some of you are still in that narrowing down process. We know kind of what you're interested in, but we want to come up with sort of a more exact problem, something you can build a model for. And some of you are in that sort of second stage right now. And then once you have a model, if you want to, run that model somehow on, if it's the sort of model you can run using, what have we been using, like Excel or something like that, you can do that. If it's not, there might be other ways to explore your model to see how everything works out. It just depends on what it is that you're interested in. So I will be here. Let me know how I can help.
Okay.
Thank you.
Sure.
I'll give them today then.
Okay, cool.
Okay, I kind of already have like I started writing the paper for the final for the project,
Yep.
and it's just like it's one of those tools that like Penn gave us like this like official, like the thing he uses to like give paper assignments out with,
Mm-hmm.
and I was just gonna turn that in, but
It's fine.
right, so but I still have to do like an actual presentation though, right?
I would like you to do an actual presentation where you're talking to the class and to me. And
Okay.
one piece of advice I give to seniors when they're talking is oftentimes by the time you give your presentation, you've been working with it so long, you forgot that not everybody understands the problem as well as you do. And if your audience doesn't understand your problem, there's no way they can understand your solution. So devote sufficient time to explain the problem. Here's something to sort of keep in mind as like a meta principle. You want your audience to, you want your listeners to know when you're coming to the end of your presentation. They'll know that you've done what you set out to do because they understood what you set out to do in the first place. If you just stop talking and it comes as a surprise to everybody, then obviously you haven't laid out what you wanted to accomplish as well as you should have. People are often reluctant to do that. They want to just jump right into their model, their solution, whatever it is, and they forget that people have no idea what it is they're trying to model, what it is they're trying to do. And that can be very frustrating as a listener. I highly recommend investing a little bit of time explaining what it is you want to accomplish.
Okay. Hey, thank you.
Sure. And in terms of length of your presentation, don't feel like you have to be between like 9 and 11 minutes or anything like that. If your presentation takes 5 minutes, it takes 5 minutes. If we're breaking it up over 2 days, if somebody goes a little over time, you've gone a little over time. Don't go like 15 minutes because that's really a little too long. But start at the beginning, say what you want to say, and then stop. So for next week, I'm going to sort of play it by ear. I will be here every day for questions. I will be here from 10, from 11 o'clock to 11:50 to answer any questions, to look over material that you're working on, whatever it is you need me for. I'm not going to continue, I think, to present next week and today. As I said, I've looked over the syllabus that I prepared and the list of things that I want to go over with you. We've pretty much done it. And so, yeah, focus on your project, and I'll just be here to answer questions that you might have.
For the final, is it going to be we're going to meet together and take it, or are you going to assign it and it's just going to be due by the end of finals week?
Yeah, it'll be during finals week, just like the rest of your finals.
Okay.
Yeah. So what I'll do is basically I am going to put a time limit on it. Like you can't have 7 days to do it or however long finals week goes. And I do that primarily so that I don't write an exam that will take 7 days to do. I'll limit it to 3 hours, and I'll make it an exam that you can reasonably finish in comfortably under 3 hours, regardless of how fast a test taker you are. And I know not everybody is the same, goes the same speed. I personally happen to be a slow test taker. When I was a student, I was always, not always, but frequently one of the last in the room, just because I sat there and plodded along and wrote slowly, and that's just me. So hopefully, no matter how fast a test taker you are, you should be able to comfortably finish this in 3 hours. What I think I did last semester is I gave everybody 3 hours and 15 minutes to finish the exam and upload their solutions to the Google Drive that I've shared with you. So yeah, that's that. What other questions do you have?
Could you upload like maybe a practice thing or like homework-ish stuff that's not really homework?
Yeah, I'll do better than that. I'm basically, so that day, and I will post things. I will post something, but we'll also have an entire lecture devoted to review, and I'll basically just tell you what's on the final, what kinds of questions you have to do, and if you want some practice stuff to do that, we can probably either do that in class, or I can write it out and put it and post it on our webpage. Yeah, just because of the circumstances of the semester, if I feel like you've mastered the main points of what we've done, then I'm totally happy. And so yeah, I'll tell you. I'm going to tell you what's on the exam as well as I possibly can. What other questions do you have?
Are we allowed to bring anything to the exam? Well, okay.
What do you have in mind?
Calculator, or can we use Excel?
Yeah.
Or
Yeah, you can bring a calculator. Absolutely, you can bring a calculator. I think I want to think about Excel. I think I am going to allow you to use Excel. I think that would be a good thing. So I probably will allow you to use Excel. You can't use your notes on the final exam. Basically, you could use sort of electronic aids, but not notes, or things like you can't copy your notes onto an electronic aid and use that. So you have to supply the information, but you can use all the computational equipment that you want. I think that's how I'm going to have it. And if, obviously you're taking your exam in the comfort of your home, so snacks are fine too. You don't need my permission for that. Did I miss something that you wanted to know, or do you have a pretty good idea about that last question? Okay. In that case, here, let me just work, ask questions, whatever you want to do. You can stay if you want. If you want to go away and work, feel free to do that. But I'm here.
I may just leave to work on because I'm having a little bit of trouble with one of the calculations, because I'm trying to figure out how to convert basically one of the equations is in distance, and I'm trying to get it so that I can derive it by time.
Yeah, I get it. I get it. Modeling, that's sort of where the interesting, difficult stuff happens. So yeah, absolutely. Feel free. Go to where you're comfortable and work on it.
Thank you.
Does everybody's project have to be as complex as that, or no?
Don't worry, Jalen. Don't worry about what other people are doing. Just worry about what you're.
Okay, just making sure.
Not everybody's problem is going to be some sort of physical thing where you're going to be worrying about distance and time and all that. And yours obviously didn't. I think I think your classmates would be interested in your problem generally, partly because it's so timely. You know, the fact that it has to do with the pandemic that we're in the middle of right now, and also everybody likes movies. I like movies, and so that makes your problem interesting too. So feel free to talk it over with your classmates. Maybe save a little bit of the surprise until your actual presentation. But yeah, also please let me encourage you, if you want to talk things over with your classmates, work together by all means. And again, some of you are still in that sort of halfway zone where you know kind of what you want to do, but you haven't sort of narrowed it down to a specific problem yet. I know at least one of you is sort of deciding between two very closely related problems.
I went ahead and decided.
What did you do?
I'm just gonna do the heat flow one.
I think the heat flow one is the one. The other one is super interesting, but I think it might be a little bit more excitement than we're ready for right now.
We can talk about it when we're back on campus.
Yeah, absolutely. Yeah, and take video of the whole process, because I'm really, or maybe we'll see some of that at your presentation, because I'm very interested. But I think the heat flow part will be much more interesting. I mean, much more doable.
And I have a question. We've been talking about heat flow like in a metal bar, like 2D, but how would I do like a cylinder?
So metal bar is 1D, right?
Or that's, yeah.
Yeah. So what you're basically doing is in 3 dimensions. You're doing heat flow in 3 dimensions, and so you're going to have like a 3-dimensional lattice where I assume you're going to break it. You're going to break it up into cells. You'll take your cylinder. And break it up into a mesh. Whatever. So like you can imagine like little sugar cubes stacked up, or little pieces of Lego stacked up to make that cylinder. And then each Lego piece will have a temperature, and each Lego piece can pass heat to its neighbors. Now, if you're like a cube, instead of having like 2 neighbors on either side, you have a top and a bottom neighbor, you have a left and a right neighbor, and you have a front and a back neighbor, unless you happen to be one of the edge cubes, in which case some of those neighbors are missing. Just like when you're doing in the bar, the end pieces have fewer neighbors. And so it's a lot like the heat flow in 1 dimension, but it certainly has it's certainly enough different that that it will make a very interesting project, I think. And of course, the outside of this thing is not insulated. That's the idea. That's where the heat goes. Heat sort of leaves through the side, and it sort of the outside part gets cool first, the inside part gets cool last. So you'll see some of the behavior that you've seen before. There might be some interesting things about the shape of the cylinder. But yeah, do you have an idea where to start?
Kind of. Like, I know I have the temperatures and everything, and I need to probably go measure the bucket, but yeah, I have all that stuff. I don't know how to account for the mixing part.
So I don't know how thoroughly you're mixing. Like, is it when you mix, is it like when you mix like a cake batter, by the time you're done, it's pretty uniform?
Yeah, so we'll like have the blenders in there and leave it going for 20 minutes and then come back.
So in that case, when the blender, so what I suggest is that you don't. So these are the 2 parts. I suggest you don't do the part while the blending is occurring, because that's a super difficult problem. I suggest the part you do is once the blender is, you just turn the blender off. Everything is sort of at a uniform temperature because it's thoroughly mixed, and then talk about the cooling at that stage.
Okay.
Is that what you had in mind, or because I think
well, kind of we mix multiple times during the thing. Like every hour we'll mix it for like 20 minutes. So every hour it's getting heated back up a little bit. and then starting the cool down process again.
Yeah, it's not really getting heated back up. It's just getting stirred around. The heat is just getting distributed. I mean, there's a tiny bit of heat. There's a little bit of heat that comes from friction. You know, when you're stirring things around and you have the molecules moving around, just like when you rub your hands together, it creates some heat. So some of that, you're warming it up a little bit. But the reason it, you know, if you stir it for 20 minutes and let it cool, the outside of the container is going to feel cooler. And then when you stir it around again, it's going to feel a lot warmer on the outside because all that heat in the center is getting distributed throughout the whole thing again. So I suggest you focus on the cooling phase. So I would start off with a really coarse mesh. You know, you have a cylinder, maybe have like, I'm going to break this up into cubes. Maybe your cylinder will first look like a, so let's see, the way I've drawn this, it's 2 by 2 by 3. So, and my cylinder looks like a brick. You got to start somewhere. And so, you know, this cell right here has a cell above it, has a cell below it, has a cell on its right, it has a cell behind it, and those are the only neighboring cells it has. And then it's neighboring the outside. Hang on for a second here. Let me change the view. I can see you. Then it has a cell on the outside, or you know, it has several walls to the outside. Some of these cells have more walls to the outside, like the cell in the top front, you know, has like 3 outside walls. And so you can set things up in Excel. Some of the heat in each cell is getting transferred out, and some of those cells are going to cool faster than other cells. And the more cells you have in there, the more you'll have like some of them toward the middle and some of them toward the outside. And so if you want, you could build this thing in Excel just like we did before, and have some of that heat transferring from cell to cell, and some of the heat transferring from the cells that border the outside from the cells to the outside, and see what happens over time. So you can actually, since you're mixing for 20 minutes each hour, I would like do the cooling, and then you mix everything else, everything gets homogenized again. So all that heat gets distributed evenly, and then it starts cooling again. You could actually do the whole process, just not during the mixing, because that's a really complicated fluid dynamics problem. I thought about that over and over again to try to get that to the point where we could work on it in your project, and it was just what are they called? The Navier-Stokes equations. There's some really complicated stuff there, and even if you make it discrete, it's still complicated. So I think the cooling part is the best part.
Okay, I have a question.
Yeah.
All right, so for my problem, well, I'm doing DoorDash if y'all didn't know.
Right.
So for food delivery, I figured that I was gonna use a random house and then use 3 different restaurants for this is gonna be like a household of 3 where they all want different food from different places. So would it be good if I do that?
Yes, for your problem, I think I would do like, if you can get a computer to sort of generate sort of random locations for the deliveries, then run your experiment over like, 100 times to see if you can sort of see what's happening on average. That would be a really cool thing to do.
Yeah. So I know for if I do that on DoorDash now, it'll give me an estimate time on how long it'll take before the food will get ready, and
That's
how long
cool.
before
I,
it takes to get to my house.
I hope you don't end up with a whole bunch of delivery on your doorstep that you're not going to eat. But yeah, so if you want to use, I know that Jalen ended up using the software from the theater that he's interested in to as part of his work. So yeah, and in a sense, your project and Jalen's project, I think, are similar in the sense that what you want to do is sort of a large number of trials and see what's happening in general. So Jalen, for you, when I say a large number of trials, I mean like different size groups trying to seat themselves in the same theater, and then you came up with those general ideas. You want to do as many trials as you want as you can to come up with the best rules for seating.
Yeah, I did 5.
If 5 is great, like if you could do more, that would be great. If you could figure out some way of sort of automating it, getting these random numbers to come in, like you want to have remember the theater, you want to make your model just like the theater's situation. They have no control over the size of the groups.
Yeah.
What they have control over is where to seat them. So if you could figure out a way of sort of coming up with a large number of these sort of random group sizes, and then you have to seat them, then that should be the most, I would think, the most helpful way of coming up with these general rules. And Terrell,
Yeah, that was the thing I was struggling with a little bit.
well, I can certainly help you with that. If we're looking for sort of random ways of doing these things, I'm sure I can help you come up with sort of ways of setting up, pseudo random numbers. And Terrell,
I think I might got an idea.
okay, great. If you do, great. If you don't, I can always help you with it too. And Terrell, if you can get again something to get these locations sort of randomly and then run it over and over again to see what's happening on average, then I think you'll be able to make some really interesting sort of general statements, which is what you're kind of looking for, these general statements that come from a large number of trials.
Okay.
Kaylee, yours is different. You're trying to model what happens sort of in every single case. That the part of the point of that whole mixing process is to make sure that the quality of the soap is consistent from time to time, that you end up with the same product time after time. And so your project is more about seeing what's actually happening, modeling it as closely as possible. So different problem, different idea. Jillian, have you and I talked? I can't quite remember. Have you and I talked about your problem yet?
Not yet. I was gonna ask if we can meet like after class for a little bit.
Yeah, or if you want, I can open up a room and we can meet now.
Yeah, that'd be great.
Let me just open up a breakout room or some breakout rooms. Okay. Oh, maybe I have to enable it first. No, that's not right. Oh, there it is. So, what interests you, Jillian?
Sorry, let me turn that off. Number one's probably horses.
Okay.
Number two, music, like in general.
Uh-huh. Well, those are, I mean, with music right away, a bunch of things pop into my head. With horses, if horses are the thing that interests you most, maybe you should do horses. But I'd have to think about it a little bit to come up with an interesting question. I mean, with music, the first thing that pops into my head are acoustics,
Hmm.
like how the shape of an instrument sort of affects its tone. That's a really interesting problem, and we could probably do something like that. That's sort of a more physical problem. I suppose if you were, if you were interested in analyzing music itself, you could pick some genre of music and, analyze the chord progressions or analyze the arrangements or something like that, and do that mathematically. That might be an interesting problem. So like music is sort of, I think of it as sort of inherently mathematical, and so right away there's a ton of interesting problems that come with music. So let me just think about horses for a second. Like when you say horses, what specifically is with horses? Oops.
Well, I do show jumping, so I would say like how they move in a way.
So show jumping is not like high jumping, right? You're not trying to get the horse to clear an extra inch, right? It's basically a set height, and you have to jump.
Yeah, you have to. So what I do, there's like hunters and jumpers. Hunters is how you look going, and then jumpers is the fastest time.
Oh, so one thing you could do is take a look at how the fastest time has decreased over time and build a model from that. And then, or you could say, take these parameters for horses, the weight of the horse, the height of the horse, the whatever, and use that as sort of a prediction to try to come up with what you predict its time should be on a certain course. That might be a really interesting problem, because that way you could have several input variables, and then the time would be your output variable, and you're trying to come up with the best model you can in terms of height of a horse, I think.
Yeah.
Okay, so
They're
height
measured in hands, so it's like 4-inch increments.
So height and weight and I don't know, anything else about the horse you can get your hands on for like a large amount of data and describe in numbers, and then use that to predict the time on a particular course. That could be a really interesting problem. And if that's your thing, if that interests you more than sort of acoustics or chord progressions, then go with that.
Okay.
So the first thing that you should do is probably see if you can get your hands on that kind of information. And if you can, then you can start trying to build a model with it.
So you said to get pretty specific with it, so I think I'll just stick to like the Olympic show ring.
Perfect. Yeah, you want to be as specific as possible. And it not only when I say specific, I not only meant by like the confines of which data you're going to allow, but I want, when you start your project, when you start your presentation, I want you to say, this is my problem. This is what I wanted to solve. I want to use these pieces of data to predict that.
So also, every Olympics, it's a different course designed. Like it has like the same like style. Like there's like a jump, one stride, then jump. Like that has to be like somewhere in it. But like it's like a different course every time.
That's interesting. Yeah, I'm going to leave that to you to see if you can figure out a way of. I'm willing to talk it over with you like next time, but I want you to think about it over the weekend. If you want to try to go from Olympics to Olympics, if there are a large number of horses, competing in the same Olympics, you can just restrict yourself to one Olympics.
Okay. Yeah, there usually is. There's a bunch.
So I will leave that choice up to you, whether you want to go from Olympics to Olympics or whether
Horse to
you,
horse.
or just, yeah. So, yeah, because that would be another interesting problem. Take the average time for the horses in each Olympics, and then see if you can figure out what makes some courses faster and which makes some courses slower. And that way, instead of measuring using the parameters of the horse, you're using parameters of the course. So these are several interesting problems, and you could do, whichever of them you want. But I would
If they
decide.
were to
Mhm.
say like knock a poll down, that sometimes adds more time. I should add that in there
I
as
think you
well?
should add that in there,
Okay.
because yeah, I would add that in there.
Even if it's only by like milliseconds.
Yeah, I understand.
Okay, so should I pick like a specific Olympic, like the year?
If you
Like,
wanted
yeah.
to do the horse
I'll probably do
characteristics
it from horse to horse
from horse
instead
to
of
horse, yeah, in that case, I probably see which one you can gather information from, like the most information from,
probably the most recent one.
and then just do that. I think that would make a really interesting problem.
Okay.
Okay,
All right. Thank you.
my pleasure. Oh, looks like everybody else left.
Okay.
Well, if you're good, then I'm good. So I will
Yeah.
just you all.
I'm gonna do a bunch of research today, and then I'll probably
Yeah.
come back to you with it.
Perfect.
Okay.
No, I like this problem.
Okay. Thank you.
Okay. Take care.
Bye.
Bye.